Guys, please check your audio and video settings, please. Guys, please check your audio and video settings, please. Yes, boss. Yesterday I was talking about what, boss? Class content, design pattern, NTSP 614, 23rd. Okay. Tell me. Other day I have shown problem related to multi-threading, guys. If if static factory method of singleton class is called in multi-threaded environment. Okay, by starting multiple threads simultaneously, there is a possibility of getting more than one object for singleton class. So that means one more door is found. We can create an extra object for singleton class without following singleton pattern. Come on, by violating singleton pattern. Yeah, what are the solutions for that problem, guys? Okay, there are multiple solutions. Number one, using synchronized static factory method. Number two, using synchronized block inside the static factory method. Number three, come on, using synchronized block with double null check, guys. This is with double null check. Okay, with double null check inside the static factory method. Okay, number four, eager instantiation. Okay, using inner class based lazy instantiation, guys. Okay, boss. Next one, using enum style singleton. Enum style singleton I will introduce at the end. Today we will see up to 5 solutions, guys. Yesterday we completed 2 solutions, but in second solution, the second solution is good. Class level locking, synchronized block is really good, but that can be improvised. That's what I'm trying to say. That can be improvised. So shall we see how to improvise, guys? Yeah, this batch admin people are very fast, guys. Right. These are the backup videos of, these are the last 6 classes backup videos. Okay, tomorrow and Sunday will be having holiday, guys. Tomorrow holiday on the view of Christmas. Sunday anyhow class is not there. Okay, next week onwards, you prepare mentally to attend class on Saturday. If needed, I will call you on Sundays. If needed, I will call you on Sundays. Anyhow, at least 2 Sundays out of 4 Sundays, you'll be having one or other common topics or common tools to attend, guys. Common topics are common tools to attend. If demand, if need is there, if things are not happening in the speed we want, I may take extra sessions on Sunday also. But Saturday, regular timings, regular class will be there. Yeah. Tomorrow is holiday on the view of customer, on the occasion of customers. Right. Now listen. Let us look at this one. This is perfect, guys. Single threaded multi, this one. Java application. See, though thread.sleep is there, whatever it is just creating only one object or not. Yeah, that's good. But let's see. Let's look at this one. Thread 1 started. Thread 1 started. Okay. Gone to run method. Thread 1 started, gone to run method. Run method has called static factory method. Came here. Come on, guys. Came here. Okay. No other thread is there inside the synchronized block. Entered. Instance double equal to nulla. Yes. Instance double equal to nulla, guys. Come on. Instance double equal to null. Thread dot sleep. Are you understanding my statement? Thread dot sleep. Thread dot sleep. Object is created, returning the object. Object is created, returning the object. Are you understanding my statement, guys? Okay. Let us assume somehow first thread has created object, guys. First thread has created object and returned object also. That time, second thread has come. Second thread start is called run method. Run method has called this. My question is, what is need of sending second thread into synchronized block? If object is already there, better to return object, na? If object is already there, what is need of again sending second thread into synchronized block, again checking for null, again, there's no need, all this stuff, right? It's better not to make second thread, which is coming after complete execution of first thread, or in fact 10th thread, which is coming after creation of first object creation, which is entering into this method after first object creation. Come on, guys. Are you getting my point there, guys? If it is not null, directly written object, what is need of doing again what? Entering into synchronized block. I'll present in a better manner. Listen carefully. First thread came, second thread came simultaneously. When first thread entered into synchronized block, second thread waited. Cool. Second thread waited. Cool, guys. My question is, okay, first thread completely created object, returned object. Then second thread entered into synchronized block. When these things are going on, third thread came freshly, fourth thread came freshly. Why third and fourth thread should go into a synchronized block? Come on. Before entering into synchronized block only, you check whether object is created or not. Yes, created, return it. When object is already there, what is need of entering into synchronized block? Think, guys. Before creating first object, come on. Before creating first object, if 2-3 threads come simultaneously, when one thread enters, other thread should wait outside. Yes or no, na? Before creating first object, let us assume somehow first thread completed task of object creation. Okay. After that task, object creation task is done by thread 1. Thread 4, thread 5, thread 6 came slowly, lately. Okay, then why those threads should enter into synchronized block? There's no meaning, na? Are you getting my point? Okay, now listen. I'll take one real life example, guys, to understand this in a better manner. I'll give one real life example. Big brother is working hard. Okay, now listen. Big brother is working hard. He's slowly started earning money. And small brother should study, should pursue education based on the money earned by big brother. But here what's happening? Small brothers and big brothers earning, small brothers study happening simultaneously. So that there will be small disturbance in what? small brother's education until big brother completes the earning, right? Okay, that's why small brother should wait and pursue the education. Slowly, one by one, he has to check the financial status of the family and he should pursue the education, right? And he should pursue the education. Come on, my dears. Understanding my statement or not? Okay. Okay. Big brother got married, guys. Big brother got married. He got the kids. By that time, big brother is well settled. Lot of money is earned. Small brothers also completed studies and a lot of money is earned. The kids of big brother should wait and pursue education, or they can directly start thinking about living luxury life. There is no need of whether money is there or not there, whether we can afford this course or not, whether we can become pilot or not, because already money is there with them, right? The kids of big brothers then happily think about doing the course whatever they want or not. I think this example you connected nicely. This example you connected nicely, boss. Come on. Okay, that means by doing double null check, one more extra null check, we can improve the performance or not. We can improve the performance or not. Okay, that means we should allow control going to synchronized block only when instance is null. If instance is not null, better to return instance directly. There is no meaning of entering into synchronized block. There is no meaning of entering into synchronized block. I think your bulb gone. Okay, guys. Right, boss. Now let's see. Yeah, this statement we are writing for first two threads who came simultaneously. First thread came, checked instance is equal to null, entering to synchronized block. Enter into synchronized block. Understanding my statement, boss? Yeah, enter into synchronized block. When first thread in sleep state, second thread came. It all verified. Instance is null? Yes, null. Okay, but it is trying to enter into synchronized block, guys. Fine, no problem. Okay, by that time, first thread sleep time over, object is created and written. Second thread is waiting to enter into synchronized block. By completing null check, it will enter into synchronized block. When second thread entered into synchronized block, third thread came into picture. When third thread started, already first thread has created object. So what is need of again getting into synchronized block? Here itself it noticed object is already there. Return the object. Sir, but second thread unnecessarily entered, na sir. Our second thread came along with the first thread, na, simultaneously with first thread. That's why it has to get into synchronized block. But third thread came when one of the thread officially created object for the singleton class. That's why third thread need not to enter into synchronized block. I think you enjoyed my statement, guys. Okay, guys. Now tell me here. This is called first null check, guys. This is called first null check. This is called second null check. This is called first null check. This is called second null check. Okay, I'm not questioning object creation. Why thread should enter into synchronized block, by waiting other thread to come out of the synchronized block if object is already created by one or other earlier thread. If object is already if object is already Array, why second null check is required? Required ra babu, second null check is required. Second null check may be required. Okay. If two threads simultaneously there, then that time. Yeah, it's waiting is avoided. It's waiting is avoided. Super boss. Now what I do, sys trace. I don't give up, that. Sys trace. Okay. Thread dot. Current thread dot. Get name. Thread dot current thread dot get name. Okay. Thread dot current thread dot get name. Thread dot outside sync block. Outside sync block. This is inside sync block. Inside synchronized block. Yes. Now come to this. This is first null check. This is second null check, guys. This is first null check. This is come to this place. I'll try to start thread 3 bit lately, boss. Thread 3 bit lately. Okay. Thread 3 bit lately. Try here. Thread dot sleep. Thread dot sleep. Some 30,000 milliseconds. Catch exception E. E dot print stack trace. E dot print stack trace. Okay. Now listen. Enter into this. Okay. Tell me, guys. Thread 1, thread 1. Thread 1. As of now, only. As of now, how many threads entered into? How many threads entered into inside the synchronized block, guys? Only one. Okay, thread 0 also entered because thread 1, thread 0 started simultaneously. Thread 1, thread 0 started simultaneously. That's why both are entering into synchronized block. Now having 30 seconds delay. Having 30 seconds delay, thread 3 has come. Thread 3 is going to come. Wait and see. Wait and see. Oh, 30 seconds is too much time. Oh, 30 seconds. Achha, it is 3 lakh. Oh, wait. Wait then. It's a 3 lakh. It has become 3 lakh. 1 minute. I cannot. 20,000. Right. 20,000. It's right now. Concentrate. Freshly you observe it. Sometimes it becomes funny. You know that. Yes, guys. First 2 threads are started. As of now, thread 1 is in synchronized block. Okay, it has got privilege to create object created. Thread 0. Thread 0 entered, guys. Thread 0 entered, guys, using the already created object. Observe. Thread 3 has not entered inside the synchronized block. Okay, is not entered into, not even satisfied first if condition. Without these lines, directly it is using the existing object or not. Are you understanding my statement, guys? Are you understanding my statement, guys? Array, first two threads start simultaneously. First thread entered into synchronized block. Second thread also satisfied what? First null check. That's why it is waiting outside the synchronized block to enter. Okay. By that time, first thread completed what? Thread object creation. So and returning object. Second thread entered into what? Synchronized block. Okay. It verifies already object is created, returns existing object reference. When both the threads completed their task was, thread 3 came. So why thread 3 should enter into synchronized block? Is there any need, guys? Is there any need, guys? Okay, guys. No. Array, when second thread entered into synchronized block after first thread creating object, this second null check will stop creating object. This second null check will stop creating the object so that it will be forced into using existing object. Got the clarity, guys? Understood my statement? This is called double null check, guys. I hope you got maturity to understand the code. Right. Right, boss. What is our today's discussion? Yes, from client application. From client application, guys. Okay. T1 dot start. T2 dot start. T1 dot start. T2 dot start. Okay. Sleep thread. Sleep for 20 seconds. T2. Then you can feel it practically, guys. T3 dot start. Yes, let us assume T1, T2 started simultaneously. Started simultaneously, na boss? Okay. Let us assume T1 entered first. Yeah, we have our presentation. After 1 year also, if you see the diagram, you should understand. What is this? T1 entered. This is A1. T1 related A1, guys. Verified. Check null. Yes, definitely null. Definitely null. Come on, guys. T1 A2. T1 A2. Come on. T1 A2. Condition true. What it is giving? Let us assume true only. Let us assume true only. Yes, it entered into synchronized block, guys. Entered into synchronized block. Okay. Entered. 1 minute. Here thread switch happened. Let us assume thread switch happened. Here itself thread switch happened. Come on. When thread switch happens, what happens, boss? T2. T2 B1. Okay. Tell me nice. Then checks the null. Checks the null. Checks the null. Come on. T2. T2 B2. True only, na? T2 B2 true only. Let us assume T2 has entered into thread switch. Synchronized block. T2, B2, B3. T2, B3. Now T1 will wait outside or not? Come on, guys. T1 will wait outside. Okay, verified. T2, B3, fine. T2, B3. Next. T2, B4. You'll get idea. Q's true. Gives true. Then what happens? Object creation. Object creation. Tell me. T2, B5. Okay. Object creation is done. Then what is this? It will come out of the synchronized block, returns it. T2, B6. T2, B6. Now tell me here. Now thread 1. Okay, thread 1 resumed back, enter into synchronized block. Now it has come back, enter into synchronized block. T1, A3. T1, A3 entered, guys. Noticed. Returns false. T1, A4. What is this? False. T1, A4. What is that, guys? Returns false. Because already object is created, right? Already object is created. It returns this one. What is this? T1, A. Can you tell me the number? A5. A5, Okay. T1, A5. It is returning existing object. It is returning existing object. Is that clear? Now thread 3 entered, guys. Now the superhero thread 3 entered. Now the superhero thread 3 entered, guys. Don't worry, I'll give numbering also. T3, C1. T3, C1. Now check, man. It checks, guys. It checks. Already object is created by thread 1. And thread 2 already used that object. Come on. T3, C2. T3, C2. Tell me, guys. Okay. Returns false. Nulla. Returns false. So what it will do? It will return the existing object. Okay. What is that? T3, B3. T3, B3. Got the point, guys? Here what? New object. Okay. Old object reference. Old object reference. Here old, guys. Old object reference. Everyone got the clarity, guys? Okay. I think diagrammatically everyone enjoyed my point. Okay, now let's think order of seeing the numbers. Order. Okay, first number 1. Okay, number 1. Number 2. Number 2. Next, what you have to see? T2 started. Switching happened. T2 started. Number 3. Okay. Number 4. Number 4. It has entered into this. Number 5. Number 6. Number 6. Number 7. Creating object. Number 7. Okay. Returning new object. Number 8. Esa no na? Number 8. 1 minute. This is one small correction. T3, C3. Yeah, this is called storyboard based teaching, boss. Number 8. Next, what happened? Next, what happened? Thread, what is the thread 2 has switched now? Okay, now it came back. Okay. This is number 3 is happening because of switching, guys. Because of switching, it happened. Okay, let's maintain single color. Now tell me next one. Right now, only one thread is there. So what happens, guys? It will enter into this. It will enter into this. What is this? Number, can you help me? Number 8. Number 8. Number 8 verifies. Number 9. It returns what? Existing object reference. Number 10. Number 10. Acha, 8 is already there. Yo, sorry, Ra Babu. Right. Number 9, guys. Number 9, guys. This is number 10, guys. Okay. Number 11. It is returning existing object, guys. Super. At that time, Bahubali has come slowly. After having 30 seconds sleep time, this fellow has come. Who is this fellow? Number 12, am I right? Number is right? 12. Verified. Verified. Already there. 13. Not entering into synchronized block. Happily returning existing object reference. Number 14. Number 14. Okay. Now tell me here. T1 thread 1. T1 thread 1. What are the steps, guys? Okay. A12. T1 thread 1 is having how many steps, guys? How many steps involved, guys? 5 steps. A12, A5. A12, A5. A5 or A3? A5 ra babu. Thread 1, A1 to A5. Okay, how many steps, guys? 5 steps. 5 steps are done. Okay. T2, thread 2, B1 to B6. 6 steps are done. How many things are there? 6 steps are there. Because both these threads are started simultaneously. Both these threads are started simultaneously. Both these threads are started simultaneously. Yeah, here what is the last step, guys? B6. B6, guys. Next, T3. Okay. Thread 3. What is this? C1 to C3. Only 3 steps. Only 3 steps. How many, guys? 3 steps. Why? Why, guys? Because why 3 steps? Because started lately after creating object for Singleton class. Singleton class. Because of first null check. First null check directly returns. Okay. Old object reference. Old object reference without entering into synchronized block. Tell me, guys, is there any internet diagram explaining like this? I hope in core Java level you might have got small confusions regarding multi-threading synchronized block. With my storyboard style of teaching, numbers based teaching, you got crystal clear clarity, boss. I hope you got crystal clear clarity. Yeah, takes a bit of time, but it will resist in your brain forever. Right, boss. Okay. So this is the one solution, boss. Sir, Sir, give me some shortcut. No double null check, no synchronized block, but problem should be solved. Multi-threading issue should not be there. Multi-threading issue should not be there. Come on, guys. Okay. This is the best solution. This is the best solution. Best improved solution. While working with synchronization concepts. While working with the synchronization concepts, guys. Super. Okay, I'll give one shortcut, guys. No need of using synchronization at all. Nothing. Is going to be a very simple solution and interesting solution, guys. You will love this solution like anything. Okay, right. You will love this solution like anything. But for that one, I don't depend upon this class, guys. I will go for save as. I'll take a printer one. Okay. Tanuja, my dear, Singleton is one object for one JVM. Across the multiple JVMs, its single object is not possible. Tanuja, if you try to dance, I cannot. Yesterday also you asked same thing. Today also you asked same thing. Understanding my point? Okay. Right. Array load balancer means, again you are deviating the discussion. Load balancer means what? Multiple objects are there. How to distribute the load? Objects will be multiple, but load should be distributed. You are thinking load balancing concept in a wrong way. Load balancer does not mean one object only will be there in multiple places. No. Multiple objects will be there running simultaneously, but the load coming will be distributed evenly. That's the meaning of load balancing. Okay, first you correct your basics, then think on that angle. Right, guys. Now listen. Printer 1, guys. Printer 1. Okay. Right, guys. Here I am going for eager instantiation. Okay, eager instantiation. New printer off. New printer 1 off. Okay, printer is equal to new printer off. Okay, here also printer 1. Here also printer 1. Here also printer 1. Now I am removing this, guys. Removing all this stuff, guys. Right. Removing all these things. I'm just taking static factory method. Static factory method. Having static factory method. That's it. Public static. Printer 1. Get in a stance. Return. Public static printer 1 get in a stance. Return in a stance. Return in a stance. Okay, guys. Now tell me what happens. Sir, you are not taking any null checking. You are not taking any synchronized block. And you are saying that multi-threading issue will be solved. Yes, guys. Whenever class loaded, this static member loads. In that time only object created. Come on, guys. In that time, at that time only object created. Now tell me. So whenever first time class loaded, object is created. Okay, 10 threads call this method, 20 threads call this method simultaneously. All of them will think about returning existing object reference only. All of them will think about returning existing object reference only, na boss. Say something, guys. Say something. Whether it is good or bad, I will come to that later. I'll come to that later. I still talk on that. But my question is, does it looking like a solution or not? Definitely looking like a solution. Let me show that, boss. Go to this place. Go to this place temporarily in okay, ticket booking operation, my dear. Stop using printer class. Start using printer one class. Printer P1 is equal to right, printer one dot get instance of. Cool. Printer P1 is equal to this one, guys. Come on. Printer 1P is equal to printer one dot get instance of. Cool, guys. Now come to this. Everything is perfect. Run the application. Done. Java application. Yeah, you start threads lately, simultaneously, whatever dances you do, guys. How many objects will be created, guys? Only one object will be created. When the moment class is loaded, not when you ask for object. The moment class is loaded, object is created. The moment class is loaded, object is created. Look at that. Look at that, my dear. Sir, no double null check, no synchronization. I liked it, sir, but I don't like it. Why, sir? Array, object is created for singleton class when class is loaded, not when you ask for object. Seriously, sir? Yes. Okay. For example, I commented this thread.slots. Okay. Here, I just loaded class. Class dot for name com dot nt dot sdp dot printer one. Class dot for name com dot nt dot sdp dot printer one. I just loaded class. I didn't ask for object. I just loaded class. I didn't ask for object. Print stack trace. Save this. Click on it. Say something, my dears. So what's happening, guys? I didn't ask for object. I loaded a class. It created object. That means though I'm not interested in object, the moment class is loaded directly, indirectly, object is created or not. Come on, guys. When class is loaded, all static member will be loaded. When class is loaded, all static members will be loaded, guys. Yeah, it is a static member. When it is loaded, object is created. See, guys, one object is good. This is called eager instantiation, guys. Singleton logic. Singleton logic through eager instantiation. Singleton logic through eager instantiation. Super. Done. Great. I didn't ask for object. Okay. Array, I'll simply ask one question. You have taken money from your friend. You have taken money from your friend for 1 year as a hand loan. After first month only, you got the money. Your friend said that no problem, you give me after 1 year, not a issue. After first month only, you got the money. Tell me, guys, you will give money to your friend after first month? No, no. That too without interest, without penalty. No, you never give. You will wait for 1 year. When friend asks, do you have money for me? Then only you will give the friend money. But these 9 months, you will try to use that money for other investment. You do some other rotations. Yes or no? Na? See, Singleton is what? When object is asked, you should create object. When object is not asked also, when object is not asked also, if object is created, it's meaningless, na? When object is not asked, why should I create the object? Eager instantiation is not good every time, right? Do you think eager instantiation is good every time? Not good. Come on, guys. See, guys. Someone asked you to come at 5:30 p.m. You have gone there by 5 p.m. Then they will think that you don't have any work to do. You are a useless fellow. That's why you came before. Come on. You have gone by 6 p.m. Everyone thinks that you don't have time sense. Both are a danger. When you should go? When you should go? Exactly at 5:30. Okay, guys. Exactly at 5:30. That's it. You should go exactly at 5:30 or 5:36 or 5:37. Not at what? Before, not lately. So then they will think that okay, you value time and you are also busy person. You are also busy person. If you go early, they think that you are not a busy person, you are a workless fellow. If you go lately, they will think that you don't value the time. So you go on time, they will think that you have a time sense. You have a time sense. So that's why eager instantiation is not good, guys. Okay, think about real practices. Real practices. Generally, caching logics will be maintained in this place. Caching logics will be developed as singleton classes logics. Okay. Cache should be created when there is a need of caching. No, I am not going to enable caching, but cache is created. Meaningless, na? Come on, guys. I don't want to. See, boss, I want to maintain a cache loading all 240 country names. But 240 country names. Now listen. If I have requirement to deal with countries or not, 240 countries are loaded and cache is created. Meaningless, na, boss? Meaningless, na? So 240 countries should be loaded into cache only when there is a need of working with countries, right? When there is no need of working with the country, it's really meaningless or not? Okay, guys. What is the fourth solution, guys? Fourth solution is using eager instantiation. Using eager instantiation. Someone asks, sir, I do eager instantiation using instance blocks. You cannot, because that reference variable is static variable, boss. You can use static method if needed. Sorry, static block. Using eager instantiation, guys. Okay, eager instantiation with the factory method. A factory method will always be there. Not a problem. Okay, what is the point I should give? Yeah, using static block or directly, we can create object for singleton class. Object for singleton class. Object for singleton class. Object class referred by singleton class. Singleton class, and we can refer that object using the private static reference variable. variable like instance. Okay. Instance when the class is loaded. This process is called eager instantiation of. Eager means early. Needed or not, eager or early instantiation of singleton class. This process is called eager or early instantiation of. Come on, guys. Eager or early instantiation of. Okay. Early instantiation of singleton class, guys. Fine, boss. Sriman Kasu, lazy instantiation of Hibernate is advantage. Okay. Lazy instantiation of Hibernate is advantage. In remaining aspects is a disadvantage. So please don't bring half knowledge in the chat box. You might have explained lazy instance as advantage in a different perspective. Don't bring everything into one context. Right. This process is called eager or early instantiation of what? Singleton class. Understanding my statement? Okay. What is the code for it? Printer1.java, guys. That's it. Printer1.java. Here is the code for it. Yeah. Since the object for singleton class is created the moment class is loaded. Since the object for singleton class is created the moment class is loaded. Okay. Loaded. So the static factory method call. Okay. Call returns the same object reference. Return same object reference for multiple times. Okay. Same object reference multiple times. Okay. Without verifying whether object is created or not. So there is no possibility of thread switchings inside the static factory methods. Inside the static and no possibility of getting okay issues in multi-threaded environment. Everyone convinced with me, guys? Entire magic is there here, my dear. Entire magic lines are there here. I hope you noticed this. This and this are the magical things. There is a one line. In one line, is there any possibility of getting thread switchings? Is there any possibility of getting thread switchings? Come on. Any chance of getting thread switchings, guys? Okay, because of single line code. Because of single line code, guys. Because of single line code, guys. Everyone got the clarity, guys? Come on. Yeah, limitation. Okay, this approach, come on, guys. This approach creates the single object for Singleton class. Okay, though it is not asked. It is not asked. Okay, though it is not asked, and if the class is loaded directly or indirectly. Okay, creating object for any class without needing it or asking for it is very bad practice. Guys. Come on. Right. Except that I don't have any complaints, guys. Except that I don't have seriously any complaints. Everyone got the clarity? I think you convinced it with my problems. Good. Okay. Now listen, guys. I do eager instantiation, but not in inner class. Not in outer class. I will do in the inner class, I will go for eager instantiation. Inner class eager instantiation looks like a lazy instantiation only. Looks like a lazy instantiation. Why? Because in outer class static factory method, when I ask to create object, then object will be created. Are you getting my point there or not? In outer class static factory method, when I ask to create object, then object will be created. Understanding my point? Okay. Let's see, guys. File save as printer2. I spent a lot of time to get the inputs of Singleton, guys. I will go all permutation and combination. We'll come to one conclusion which is best later. First, you think about all permutation and combinations, guys. First of all, I think you know inner classes. You know inner classes or not? Tell me, Java supports how many types of inner classes? Java supports how many types of inner classes? 4 types of. What is the first type? Normal inner class. Second type, nested inner class. Number 3, local inner class. Number 4, anonymous inner class, right? Number 4, anonymous inner class. What do you say, guys? Yes or no? Na? Right, guys. This is my printer2. This is my printer2. This is my printer2. Okay, guys. Right. This is my static factory method. Return type is printer2. This is normal outer class. Okay. Now I am taking. Okay. Now I am taking static inner class. Static inner class also called as nested class, right? Nested class. Nested inner class. All are one and the same. Okay. Tell me, can I keep private modifier for a class? For outer class, no. For inner class, yes. For outer class, no. For inner class, yes. Understanding my point? Our inner class is also like another variable, another method of the outer class, ra Babu. So inner class variables can be private, na methods can be private. So outer class variables and methods can be private, na. So inner class also can be taken as private. Okay, private static. Okay, guys, private static. Okay, printer to inner. Some name ra Babu. Printer to inner. Private static class. Don't forget that. Printer to inner. Printer to inner. Are you understanding my statement, guys? Printer to inner. Come on. Printer to inner. Here, printer to is equal to outer class object only I'm creating. Okay. Private printer to is equal to. Okay, I'll make it private static. Private static printer to is equal to new printer to off. New printer to off. Array inside inner class, I am creating outer class object. Okay. Inner class based eager instantiation. Okay. Inner class based eager instantiation from outer class. Okay, it is lazy instantiation. From outer class, it is lazy instantiation. Array, inner class can access outer class, huh? Yes, we can access. Here is the proof. Come on. Are you getting my point? Here is the proof. Okay. Right. Now come to this. Tell me, guys. Inner printer inner. Okay. Printer to inner dot instance of. Printer to inner dot instance of. Okay. Now tell me, guys. When printer to loaded, any object is created? When printer to loaded, any object is created? No. In printer to class object is created or not created? Not created. Clear, guys? But when I call get instance method on printer 2, when I call get instance method on printer 2, come on, guys. When I call get instance method on printer 2, okay. When I call get instance method on printer 2, what's happening, guys? Printer 2 dot instance. Printer 2 dot instance. Array, in order to load member variable, first of all, class has to be loaded, na? When you call static member variable on the class name, first of all, class loads, then member variable loads. Array, when class loaded, static variable loads. When static variable loads, object is created. But when the object is created for printer 2, when you call the method, when you demand by calling method, that means indirectly it is lazy only, na? Indirectly it is on-demand object creation only, right? Indirectly it is on-demand object creation only. Okay. Not convinced, huh? Wait a minute. Okay, now I called printer 2 dot get instance. Control has come here. Look at this line. Printer 2 inner dot instance. It is a static property. In order to load the variable, first of all, class has to be loaded. When class is loaded, static property loads. Come on. Static property loads. When static property loaded, there is an object creation for printer 2. There is an object creation for printer 2. Come on, guys. Now tell me, guys. When I call get instance method, then only inner class is loaded. Then only static property based instantiation is done for outer class. So indirectly it is lazy instantiation, eager instantiation. Lazy instantiation. Come on, guys. Is there any lazy instantiation or not? Definitely lazy only. On demand only object creation. Got it, guys? Okay. Now you may ask me, sir, there may be a multi-threading issue. In Jaeger instantiation, the moment class is loaded, object is created. The moment class is loaded, object is created, and there is a single line statement in the static factory method. When there is a single line statement in static factory method, is there any chance of getting thread switchings, boss? Is there any chance of getting thread switchings, boss? No. So no thread switchings, no multi-threading issues. No thread switchings, no multi-threading issues. Got it? In your brain somewhere in the corner, you studied a lot of core Java concepts. They might have got a lot of dust because they are not being used for so many years. Okay, now I will remove the dust from those concepts and I will show how it can be used in design pattern. You will get goosebumps. Come on. I hope you are enjoying. Tell me, this course is worth or not? When someone by mistake asks you, can you develop perfect singleton? Can you develop singleton with all standards? So you have multiple solutions to give to them or not? Okay, guys. Don't worry. At the end, I will write perfect singleton that has to be written to interviewer. Right now, I'm showing all permutations and combinations. Okay, guys. Printer to P is equal to printer2 dot get instance. Printer2 P is equal to printer2 dot get instance. Let's see, guys. Now you just go to multi-threaded environment only. Java application. Okay. See, first object is created. First time object is created. Yeah. Maybe threaded dot sleep is taking time. Which, 1 minute. Now listen. When class is, this is loading printer 1. Okay, don't go for printer 2. When class is loaded, any object creation, guys? When class is loaded, any object creation, guys? Any object creation? Empty window. Empty window. When class is loaded, any object creation? No. Okay, you start multiple threads. You start multiple threads. Any multi-threading issues? Let's see. No synchronized block is not there. No synchronized block is not there. Double null check is not there. Are there any multi-threading issues? 2 threads started simultaneously initially. Only one object has come. Only one object has come. Yeah, third thread has come. Tell me, guys, only one object is created here or not? I think you got the thorough knowledge of this. Okay. Right, boss. Whatever you thought so far, leave it. Okay. Whatever you thought so far, you leave it. Okay. Think about other permutations and combination. Yeah, this is limitation. What is the last solution, guys? Sorry, fifth solution which I want to give. No, this is inner class based lazy instantiation through outer class. Okay, actually, it is also doing eager instantiation. From outer class perspective, it is lazy instantiation. Varada Santosh. From outer class perspective, it is a lazy instantiation only. Got it? 10,000 guys. Right, guys. Paste it. Client application, guys. Client application. Okay, here what is the point I should write? Okay. The outer class object. The outer class object. Nothing but singleton class. Is created. Is created inside the inner class through inside the inner class through inside the inner class through pre-instantiation process. Inside the inner class through pre-instantiation, pre or eager instantiation process. Process only when that inner class is indirectly asked to load using the outer class static factory method. Outer class static factory method call. So we can say it is on demand basis. Okay, on demand basis, lazy instantiation for outer class, nothing but singleton class using inner class eager instantiation support. Okay, inner class based eager instantiation support. Okay, guys. Right, guys. Right. Here also, multi-threading issues will not be there. Issues will not be there. Here also multi-threading issues will not be there. Are you comfortable, guys? Here also multi-threading issues will not be there. Here also multi-threading issues will not be there. Come on, guys. Here also multi-threading issues will not be there. Because of single line logics we place in static factory method. Static factory method. I think you enjoyed today's session, guys. Okay. This is good solution among the third and fourth. Among the third and fourth, among the fourth and fifth is the best solution. Among the first three, third one is the best solution. Understanding my statement, guys? Okay. If you use that, we don't use this. If you use this, we don't use that. Sorry, enum based solution still not given. I will give. Okay. Among the A comma B comma C solutions, among the A comma B comma C solution, C is the best solution. C is the best solution. Got the point, boss? Among the D comma E solutions, among the D comma E solutions, E is the best solution. Right, guys. D is the best solution. There is no limitation in this. In this eager instantiation process, this is best. Okay. In this synchronization concept, C is the best. And for enum, there are no multiple solutions. But enum style, I will not introduce today. I will take time to introduce enum style. At the end of all things, I will introduce enum. Because if I introduce enum style solution, you never feel interest to study other solutions. You never feel interest to study other solution. That much crazy solution it is. And it is the latest and crazy solution, guys. I will give at the end solving not this problem, all the problems at once. Solving all the problems at once. Right. I think after listening Singleton Java class from your explanation, why interviewer is unhappy so far, at least you realize it now. So, come on. At least you realize it. You might have gone to interview, you asked about Singleton class, you explained very confidently, but interviewer kept unhappy face. Interviewer kept unhappy face. Why? Because you have developed what? Not further interviews. I am talking about completed. Previous interviews I am talking about. Further interviews, anyhow, you will do well. Previously, you have just developed Singleton with minimum standards. Then he realized you don't know depthness of the Singleton. Are you getting my point? Now, after completion of this design pattern in the classroom, you go and write perfect Singleton. He will appreciate you and you will see happy smiles in his face and in his eyes also. In his eyes also, you can see happiness. Right, guys. Everyone enjoying? If anyone is not enjoying the way I'm presenting design pattern, okay. You should check your core Java basics. You should check your core Java basics. Just now I have shared Design pattern backup videos, guys. 5 backup videos or 6 backup videos. These are the 6 backup videos. And here onwards, no backup videos will be given. Okay, every day you have to attend live class. Okay. Abhishek, if I take core Java, you don't enjoy my core Java. Why? Because since you already know core Java, you are enjoying my depthness. But in real core Java level, when you are learning core Java for the first time, if I teach this kind of core Java, you will run away from Java. So that's why pray God that I am not there in core Java. Understanding my point? HKSR is the right person to stay in core Java. Okay. Why? Because HKSR is the right person to enter into core Java. Fine, boss. How to study for this subject? Just follow documents of the classroom. Right. Right. Fine. I hope every day you are keeping satisfactory face. Something you learn today kind of face is coming at the end of the class. At the end of the class. So that's why be active, be interactive. I have a lot of subject. I have a lot of analyzation. I have a lot of things to share. If you show much interest, I will share much. If you show less interest, I will share less. I'll share less. Okay, guys. Thank you. Have a nice time. We'll meet tomorrow. Sorry, we'll meet on Monday. Next class will be on Monday. Next class will be on Monday.